Hi everyone, this is a review of the Do Now from 325, and in your Google Classroom it's called 1.3.7, and this corresponds to page 40. And this is the elaborate towards the bottom of that workbook. So we have to do problems 14, 15, and 16. So this is relatively simple. They're just asking you in general, if you have a new function g of x, how is that transformed from the parent function f of x? And so I've put in the parameters a, h, and k. I believe everyone knows what they represent at this point, but they want to know what are the general rules for graphing. So to graph this new function g of x, if k is positive, you're going to go up by k units. If k is negative, you're going to go down by k units. If h is positive, you're going to go to the right h units. RT is my abbreviation for right, h, and then units. If h is negative, you're going to go left. If a is negative, you're going to reflect the entire graph over the x-axis. Now again, I know that h sometimes becomes a bit of a problem, but please remember there's a negative there. We'll address it again for number 15. Given f of x equals a times x minus h squared plus k, what are the steps to determine the parameters a, h, or k? So again, let's take a look at this. And in this instance, you could be looking at the graph. You could be looking at the equation, and you need to know what they are. And again, what do they signify? So remember, if the absolute value of a is greater than 1, that would be outside the front of your x term. If the absolute value is greater than 1, you encounter a vertical stretch. So your shape gets pulled long and skinny along the y-axis. If the absolute value of a is in between 0 and 1, I apologize, it's a little bit squishy there, but if it's between 0 and 1, 1/2, 2/3, 1/8, 0.2, 0.7, 0.62, all of those are going to result in a vertical compression, which is a squishing of your function along the vertical axis. If k is positive, you're going to go up by k units. If it's negative, you're going to go down by k units. And again, you're going to be able to determine that without even drawing it, but just by looking, if you're given the vertex form, you'll be able to see the k right off the bat. If h is positive, we're going to go to the right h units. If k is negative, we're going to go to the left h units. Now remember, going back to our formula here, there is a minus in there. So a minus next to a positive is going to appear as a negative. But if I say what is the value of h, you should be able to tell me h is actually positive. So just remember, in the house, horizontal, the opposite of what I think. That's our general rule for actually determining what the transformation has been. Let's go to number 16. What are the possible types of transformations that f of x can encounter? So again, f of x is a generic. It doesn't tell us that f of x is x squared, which is a parabola. But we're used to working with that, so let's talk about this. Again, the transformations are vertical, up and down, and we would see that in the parameter of k. We can also have a horizontal transformation, left or right, and we would see that in the h. We could have a vertical stretch or compression, and that would be looking at the a by the absolute value. And again, I'm very detailed here, but if you just said in here, a tells me vertical stretch or compression, what does the h says? Horizontal translation, and the k is a vertical translation. I'm okay with that. And lastly, if the b value, now remember the b is inside the house, but we talk about it being to the left of the x. Sometimes this coefficient has to be factored out. Sometimes it has to be factored out, but sometimes it's obvious to see. So if the absolute value of b is greater than 1, now if this were outside and was a vertical dilation, it would be a vertical stretch. But because it's inside the house, it's the opposite of what we think. So this results in a horizontal compression of 1 over b. Or if the absolute value, I apologize, I didn't write them in there. If the absolute value of b is between 0 but less than 1, you experience a horizontal stretch of 1 over b. Okay, and again, it doesn't have to be that specific, but those are the general transformations that can occur with pretty much any function. All right, good luck. Have a great day. Classwork coming next.